Do you think Agile development methodology is just for software? In this video, I want to show you how to use Agile in a hardware prototyping process to get a better product that people want faster than you thought possible. Let's get into it right now. So let's talk a little bit about Agile product development. And this is from a prototyping perspective. The big idea with Agile is that at each stage you get customer feedback. This is the key part here. I think a lot of people misinterpret Agile as a way to continue and chunk up the development process. That's not really what we're talking about. If you go over here, this is what's called the Agile loop. The build, test, and learn. The build is important. This is called a minimally viable product. Other times people call this the minimum lovable product. That's the new trendy thing here that gets people excited. That's fine. The reason that I like that is that it hints at that the big deal is real customers. That's the testing part of the Agile loop. You need to make sure that you are actually testing whatever you build with real customers. And we'll get into how to do that. But this is a critical part. This is not just chunking up the build process. If you're not talking to customers, you are still building. Now, there's nothing wrong with still building, but you're still building. Testing happens with real customers. Only from real customers do you learn. And you want to be testing and figuring out this loop that you're learning one thing at a time. That's really a key point here. The less that you learn, the more that you learn. That's the paradox here. Now, obviously, you're going to learn a lot of different things, but what you want to try to avoid is trying to build too many things here to test too many things in front of customers where you don't really know what you learned. It's part of the scientific method and the scientific process here, and a lot of my listeners are scientists or at least engineers, where you understand this a little bit intuitively. You're trying to control the different variables that you're testing so that you really know which of the things that I tested am I really learning. So if I have 8 variables and I'm trying to learn, it's very complex to know which of those 8 variables actually meant. It's very difficult to know which of those 8 variables you're actually learning from. If you're only testing one thing or maybe 2 things, much easier to tease that out. And then what you learn, you go back into the build process and repeat. This is the basic idea behind an Agile loop. And it was the software folks that figured out how to make this work, because software used to be in what's called a waterfall methodology. And you might be familiar with this, where you define all of the specifications up front, and then you chunk those apart on something like a Gantt chart. That's why this refers to and looks like a waterfall. There are times and places for each of these 2 different methodologies, but what I want to show you in this video today is how to think about Agile product development from a hardware perspective so that you can get faster learning and a better product. And the key thing here is a product people actually want. That is the biggest thing. And Grant Martin talks about this on the Invent With Me podcast. Going to like and subscribe that. I'll leave a link in the show notes. That the biggest issue is not getting a patent. It's not getting funding. It's not any of those things. It's actually building a product that people want and people buy. That is the critical thing. So the faster you can learn that, the better. So Agile is a methodology where you can actually learn faster and get to this point quickly. Now, again, because this is a sequence where you're going to be going through multiple iterations, it may seem like it takes longer. But if you get to market faster with a product no one wants, did you really get there faster? I would argue that you didn't. So how do you do that with a hardware prototype, not software? Software is easy. There's no real cost. There is cost, of course, and now with AI, there's token cost. But you get the idea. There's a lot less cost because there's a lot less physical things to do. So let's talk about how we might do that. And I have a 3-step process for doing that. The first step here is what I call a paper prototype. I'm not the only one to call it that. That's a pretty common way to think about this. This is the loop 1, build, test, learn. See that right there? This is your first loop. What you are building, you are describing your idea in a paragraph or a picture. Have a little drawing. Have samples that you've purchased that you've kind of marked up. That is totally fine. Your idea here, what you're testing is you're asking real buyers about this, and do they get it right away? This is really critical. If they don't understand what you're trying to do fast, you have learned that you need to keep in this loop until you really learn that someone says, okay, I get exactly what you're willing to do. Then and only then can you move to step 2. The benefits here, low cost, low time. So I was helping a client, boy, it must have been 2 decades ago now. He was developing basically a sticker that would adhere to the back of cattle to tell when they were in estrus. That means they're ready to be artificially inseminated. And this is a critical idea in it means a lot to farmers and dairy farmers. If you miss those pregnancy cycles, it's a big deal. The first thing he did was he essentially said, well, I need to have a sticker that goes on the back of a cow. He actually got lottery tickets. And because he wanted to say, hey, you've got this scratch off ticket when it scratches off the animals in estrus. He had lottery tickets and he had stickers, different types of stickers that he bought. And he went out there and said, if I combine this with this and put it on the back of a cow, do you get what I'm trying to do? And people said, yeah, I totally understand what you're trying to do. I've got questions about that. I'm kind of interested in this X, Y, and Z. What color am I going to be able to see that color when it scratches off? How adhesive is that glue that's on there? Is it too adhesive? Is it not adhesive enough? That's great. Those are things you learn. But again, people understood what that prototype was right away. So he was ready to move on to step 2. Step 2 is what I call a breadboard. And in electronics manufacturing, this is actually a technical term, but I like it here for its implication. You are trying to build a janky working model. Okay? What I mean by janky is you do not want it to look nice. That is not the point. You're talking about form over function. So there's that difference between user experience and user interface. How it works, how it looks. You're focusing on user experience. How does that function work? And what you're trying to do is validate one feature at a time. Remember what you learned back here, we need to control these variables. So what we're trying to learn is how the customer expects it to work? So in the case of my client here, he was testing different scratch-off methods and what colors were underneath there. And he discovered that the colors that were the most visible when you're taking a look at 50 or 100 or 200 head of cattle were bright red, bright yellow, bright green. Some of the other colors like blues reflected in the sunlight and they just couldn't be seen as well. So red was the big color, but yellow and green also could work. When you do that, there's lots of different ways to actually build a breadboard prototype. Arduino is the electronics board for that. If you know, you know. But I've seen people use wood, use Legos. I've seen people do this successfully. Recycled materials, anything cheap and available. I mean, just frankly, putting paper together like popsicle sticks and glue. Trust me, the key thing is really understanding how to make sure that this works the way customer expects it to work. So you want people focused on the function, not the form. So if people are tied up, if you put your logo on there and you've got all this work you've done in the design, people could be focused on the design and not the experience. Need people focused on the experience. Otherwise, you're confounding your variables. So again, stay janky, my friends. This costs a little bit more money and it takes a little bit more time. And for every key feature the product has, you need to be running multiple loops. So each one of these is a little build, learn, test loop. So if you've got 3 features, you need to do this at least 3 times. This is a 2 sub n. You could be doing this many times depending on how you continue to learn. But think about what happens when you have validated all your features. People get it. The features work as they expect them. Now, then and only then can you go to a working model. And this is key. A lot of people think, well, this is the time where you go to manufacturing and you get dies made and you get tooling. Not yet. I recommend having that be kind of your final gate when you go to tooling and, more of your mass production. This is a working model. This is where you can start to work in form elements as well as functional elements. So you're thinking about maybe 3D printing, short run domestic manufacturing. You're testing here, you brought all of this together. Does it actually build excitement? And here's the key thing, okay? These are the questions you're asking here. Sorry about this. I'll draw this a little bit better in the future. But is my excitement building or shrinking with this? As I go back to the same customers and they're looking at this develop, are people starting to ask, when can I buy it? You get this. This is what they call in sales a buy signal. Okay? Does it have too many features? Is the key thing, maybe the key thing is this right here, but is this and 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 all these other features you have, are they confusing the customer? Do you need to strip things out? Okay. Also, people think about, well, what do I call this? How do I brand it? What's my name? This is right here. People are going to start calling it something. They'll have a name for it. There'll be some inspiration in here. And this is where you can work on your branding. Now, obviously, during this entire process, people will obviously think about, well, when during this cycle do I start to file provisional patents? When during this cycle do I finalize my branding? When during this cycle do I come up with a website? And what I would tell you is, talk with a qualified attorney for when during this process is the right time to file a provisional patent. But here's the thing. I wouldn't be doing any large-scale marketing at this time. I would be focusing on small-scale customer engagements, people who are actually customers, real buyers, friends, family like you, but they do not count. These should be people you do not know. This part is critical. You don't want their opinion of you clouding the opinion of the product. Again, if they know you, it's just one additional variable in here you need to control for. You want to control for as many as possible. And you get up here the most time and the most money before you go to tooling. Most of the other things, you don't want to spend more money during this process, because the more marketing and the more things you do, the more it locks you into this waterfall methodology, where if I've got a patent or I have a trademark, I have a name of the product, those become things that are locked. And it's very difficult to go back up the waterfall and fix something once it's been done. But Agile is designed for continuous improvement and continuous learning. So in the end here, my client actually had short-run manufacturing. He had a printer work up a few different options, different sizes. Some were a little smaller, some were a little bit bigger, and actually went out to the dairy farms to test them out and actually tested them in real circumstances over the course of 2 or 3 weeks, and pretty quickly figured out exactly what size these estrus alert tags needed to be. This was maybe 15, 20 years ago, and today they are essentially common practice on every dairy farm that you might visit. So again, this process absolutely works, and Agile is not just for software. So when you think about this, chunk this into 3 steps: paper prototype, breadboard, and working model. You do that, there can be additional steps within each of these, but make sure that you're moving as you go, kind of step by step, because the investment in money and time will grow. But remember, what you're getting at isn't the money, it's not the time, it's that you are working to get to the fastest way possible a better product that people actually want. This is the only way you know it.
That's it for this video.
What questions do you have about prototyping your hardware invention using the Agile methodology? Ask your questions in the comments and I'll answer them, or I might even do them in a new video. Until then, see you on the next one.